Welcome back again, my friends. This video going to be part of CCNP 2.0, that is new concept implemented in Cisco CCNP route or a route, that is 300 100 in 1. So very beginning you can see right there a network principle identifies Cisco Express forwarding concepts. Earlier, this topic was part of CCIE routing and switching. But now, since it's included in CCNP 2.0, we need to understand what is Cisco Express forwarding, how does this work, where it used. So there is subcomponents of Cisco Express forwarding is FIB and then after adjacency table. So hopefully after this video you will able to understand Cisco Express forwarding. I strongly recommend you go ahead and download this PDF, that is I tried my best to create this document for you people and also available free for you. Download from the YouTube, okay, and then after go through me or go through video, I should say. So to understand CEF, let discuss little bit about a packet switching technology. Make sure this is not layer 2 switching. We are talking about layer 3. So layer 3, it could be router or it could be a switch, that is layer 3 switch. So there is three technology or a three way, I should say, using which your packet forwarded by a layer 3 device, maybe router or a switch. First one is known as process switching, that is used from very beginning, and then after fast switching, sometime also known as demand based switching, and finally the Cisco proprietary Cisco Express forwarding or CEF. So good. Now we are going to discuss a summary, not whole bunch of lines, whole bunch of word, whole bunch of string. So good. I also created a summary so that it will be easy to understand for you people. So we have three methods to forwarding a switch or switching a packet, means on layer 3 switch or a router, process switching, fast switching, and Cisco Express forwarding. So begin with process switching. How does your process switching work? To understand it better, we need to go through let me take my pen, go through a concept or a diagram, I should say. Suppose this is a router, a computer connected right there, and another computer is right there. So one is left hand side and another is right hand side, computer A, computer B. So somehow computer A want to send data to computer B. First it send data to the router, since your router being a gateway or a work like a gateway. So router receive that particular packet, and then after what your router do with that packet, it work multiple tasks with this packet, whatever is received from the computer A or might be computer B. So it alternate layer 2 addresses. So while computer A is sending that frame, it put the MAC address of computer A and destination MAC address of router. So your router going to strip off the source MAC address as well as the destination MAC address, and will enter or attach the source MAC address of this interface and destination MAC address of this computer. In fact, it going to check your packet, that is CRC checking. So how does your router come to know what is the IP address, MAC address of computer B? Obviously it use ARP, and then after it going to, means actually it's use couples of tasks to forwarding particular packet. it also looking routing table where it need to forward which one is the exit interface or exit interface, I should say more accurately. So every time with every packet your operating system or iOS going to involve along with your hardware to find a destination address to forward a packet or switching a packet, changing the layer 2 address, look up the next hop or a destination layer 2 address, and then after finding the route or a route based route to forward. So this is more CPU intensive. Every time with every packet your router going to create more CPU cycle, result slower speed obviously. So at beginning this was initial steps to work with for a packet forwarding, but later on fast switching or sometime also known as demand based switching technology take place. So let's discuss little bit about the demand based technology. In demand based technology it was similar to process switching, but it maintained a cache, or I should say the root cache. A root cache is nothing special than the recently information that your router use it keep or a cache. What I mean to say that in previous example we have a router, a computer A and then after computer B. So every time your router go through finding the routing table, finding the next hop layer 2 address and some other task. So why not you create a cache, means recently you going to forward a packet from computer A to computer B, or there is a flow bunch of packet going to forward from computer A to computer B. Every time you don't need to go through the router lookup and next hop address lookup and all those things. You can cache those information and use that information while you detect the same flow. This is what known as fast switching or demand based switching. So it keeps recently used next hop layer 2 address, exit interface in routing table as well. So when it used while a flow is nothing special than a traffic from same source to same destination, going traffic known as a flow. So they use root cache. If your data going somewhere else, again it going to create another cache. So that is good. So now because of this, less CPU intensive and then faster than previous technology. But there is little bit problem with caching. Sometime cache updation may take time. What I mean to say that earlier you may have a cache, all those information to forward packet from computer A to computer B you have cached. So maybe your computer B or maybe this is a router taken out and connected to some other port or some other link. Now it need to be updated since it store a wrong information, means not converged, because you change the port of device. So this is little bit problem, not a large problem, not a big deal, but yes there was. So fast switching is obviously faster than the previous switching technology. Later on Cisco used their own proprietary way or a technology that is known as Cisco Express Forwarding. This is similar to fast switching. Fast switching is nothing special than keep a root cache or recently use routing and forwarding information, and it maintain, but it use a dedicated hardware that is known as ASIC. Application specific integrated circuit. this is performed by ASICs, not performed by CPU of your router or CPU of your switch. So your Cisco Express Forwarding actually maintain two components. One is known as FIB, that stands for Forwarding Information Base. It's similar to a mini routing table. In rest of layer 2 addresses and layer 2 information maintained by the adjacency table. Now this is minimum CPU intensive, faster speed, either sometimes also known as wired speed. So whenever anything going to change, immediately your FIB and adjacency going to update. Means if you're talking about the fast switching, there may be cache updation problem, but Cisco Express Forwarding, as soon as possible, means as topology changes, as see here, topology based switching, sometime your Cisco Express Forwarding also known as. So whenever your topology going to change, immediately your FIB and adjacency table also going to change. You can go through a lot and discuss about Cisco Express Forwarding, since this is documents I have created for you people. So I'm not going to go through line by line. Yes, you need to understand Cisco Express Forwarding uses specific hardware, that is known as application specific integrated circuit. So ASIC are used to accelerate layer 2 and layer 3 switching, store and processing QoS, security, ACL, and maintain net flow statistics. So this is the typical example of that particular hardware. So as I told you earlier, CEF has two major components, or have two major components: forwarding information base table and adjacency table. I have also described what is forwarding information base. This is conceptually similar to a routing table or a routing information base, and adjacency table as well. So adjacency table maintain layer 2 or switching information linked to a particular FIB entry. So your router also going to create a adjacency table so that it know the layer 2 information: cache adjacency, reverse adjacency, null adjacency, punt adjacency, glean adjacency, and so on. So these all things I have described in documents. Please go ahead and download documents. That's why I am emphasizing again and again. This is very good documents as per my effort. So null adjacency, that is similar to null interface, all packet going to drop. In receive adjacency, that means your router itself. And punt adjacency, a special handle or means special handling required or cannot be switched by CEF. Cisco Express Forwarding may not work with such kind of packet that is also going to create adjacency, that known as punt adjacency. Glean adjacency are directly connected but does not have the destination MAC address. So all those things I have described in this PDF. So CEF can be work in two mode: centralized CEF and distributed CEF. What is the limitation of Cisco Express Forwarding? Your Cisco Express Forwarding will not work when a packet has some header option, TTL expire, or the destination address is tunnel interface, or unsupported encapsulation, or exceed maximum transfer unit. So on that time your CEF not going to work, then normal switching will take place. Great. So verifying CEF, enable by default. So CEF is enabled by default on Cisco devices. which have that facility or that hardware that we talking about, you can just disable using no IPCEF on global command. So let's see, I'm going to use a topology where we can go through, verify the concept, and then how we can verify those things. So alright, this is the topology that we are going to work out. Right now I'm using 2901 into 3, that means 3 router. The name is HQ1, branch 1 and branch 2. This is running Cisco iOS 15.0 router. So you can also perform this task on layer 3 switches. Since this video I am going to show you how to work with Cisco CEF. So we have also applied the IP addresses, that is 200.200.x.x. There is 0 network, network 1, in the stop 2, 3, 4, 5, 6, 7. These are the loopback addresses going to connect with branch router 2 as well as headquarter router 1. And then after, I also used OSPF as a routing protocol so that they come to know the routes or they exchange their routing information using the OSPF. So first I would like to show you. So this is my console window. I can see this is my terminal server. This is not more required right now. Let me close this one. These devices are working. If you run a command, so running config, you will find Cisco CEF or Cisco Express Forwarding is already up and working. So let me go ahead and create some traffic so that they create their topology and all those things. I don't think I need to create a traffic. Let's see, let's verify. So IPCEF, and then after you will find let me create make little bit larger to show all those things. There we go. So we can show IPCEF prefix 00000, no route exists, means default route. If any packets originated 0000, go ahead and drop it. 00000 received, that is you are a self. Similarly, loopback address going to drop 200.200.0 network, that is attached to you, or serial 0/0 interface, as you can see right there, and so on and so forth. These all information you can see. And to reach the network 5, 6, 7 is connected to branch router 2, you can go ahead and send packet to the next hop 200.200.0.2, that is branch router 2. This is your next hop address from which you can able to reach all 3 network, that is 200.205, 6 and 7, and these are the IP address that are actually connected. This shows 32-bit because these are the loopback addresses and I am running OSPF. And similarly, the multicast need to drop, and multicast originated from these receive means directly connected to you. These things actually I have already described in the PDF file. You can go ahead and find the adjacency table on detail of adjacency. So this is first one that we can describe. Your Cisco Express Forwarding is working. You can see to the particular interface, so IPCEF, and then after it could be VLAN or it could be a interface. So IPCEF, and then if you put the question mark, you will find everything. Right now I'm going to use serial 0/0/0/0, and then after a parameter using detail. So it's also going to tell the all information. We have how many prefix we have, 28 prefix, the networks, and then belong to So you can again verify. So covered dependent prefix to, need to, tick to, and all those things. And to verify adjacency table, so adjacency, and then after you can summary or you can define particular interface as well. So this was so interface port channel line. Actually it is running on layer 3 switch, I hope so. So last, I think not last one, this is so adjacency. And then what kind of adjacency you looking for? So adjacency, and then after the particular mode or a port channel number and detail or so on. Let's see, I can use so adjacency, and then after my serial interface, so serial S0/0/0, and then after detail. Let's see. So this is what the all about to particular interfaces. You can verify to point-point network and packet, since no one packet going to send and receive yet, so not going to see all those things, but yes, all other information that we have we can able to see, and we can verify the Cisco Express forward. So okay, now I am also going to verify on branch router. This is let me show you. This is the middle one router that is located or situated right there. This is branch 1. It has 2 neighbor, so it's supposed to have more information. So let's see, so IP CEF, and then after I can use detail and all those things, but let this run as it is. Obviously the next hop addresses and then exit interface we can see right there, and so adjacency table, or let's go through the detail. So adjacency, we have 2 interface, one is gig 0/0 and second one is serial 0/0, and the IP address and then the MAC addresses that going to be used. So this is the MAC addresses. These are going to maintain on your adjacency table. We are going to looking for layer 2 information. So as I discussed earlier, this will be storing adjacency table. So far we have discussed, I think, most of thing. Let me verify is there anything is left. So we have run command, so IPCEF, so adjacency, or you can just run without detail. So adjacency, please. These are the adjacency, gigabit 0/0 and serial as well. And what? Yep, I think I have finished all those things. So I hope this is informative for you, and I would like to say thanks for watching.